all the slopes of all the secant lines, 2, 1, 1, blah, 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 0.9999, and so on and so forth. So just looking at these numbers, we have to come up with, so maybe I should share my screen first and go back to the problem. Here it is. And then they're asking us, using the results of part A, guess the value of the slope of the tangent line. And using the slope, find the equation. Okay, fine. So, can anyone guess? Right? So, what this is saying is, we are coming from both directions with 1.5 here, 2.5. Closer. 1.9, 2.1. Closer. 1.99, 2.001. 2.01. Closer. 1.999, and then 2.001. But we really want to estimate this. Can anyone estimate or try to estimate? You can say, it's not close enough. You can say, I think that 1.999 is not close enough, or 2.001 is not close enough to 2. Fine, I will agree. And then I don't want to damage what I have. So, okay. Or from the other side. So can we come up with an estimate then for the slope of the tangent line at P?
Is it 2?
So let's read these numbers. 2, 1.11, 1.01, 1.001, and let's read these numbers. 0.66, 0.90, 0.99, 0.999. So
it should be 1 then.
Aha! Great job, indeed. So indeed, the slope of the tangent at P is 1. And knowing that the slope is 1, I have y minus y1 equals the slope times x minus x1. And as I mentioned, that's a big deal. The slope of the tangent is a big deal, and the equation of the tangent is a big deal, where the slope is 1 and the given point is 2, negative 1. So then I have y plus 1 equals x minus 2, and I move 1 to the other side, y equals x minus 3. So the rate of change, the instantaneous rate of change, if that function were distance, I would have said it would be 1 at P, and the equation of the tangent line, which is again a big deal, is y equals x minus 3. How do we feel about this?
I mean, the math makes sense to me. I'm just having trouble understanding the tangent at P, I guess. Like, actually, never mind. I don't really even know what to ask. I'm good.
So initially we had this point P and we had Q, right? So this is at x equals 2. And this one was at 2.5. And we determine a slope. Then we had P at 2 when x equals 2, and Q was closer. So this is the secant line now. So this was at 2.1. The next step was P here, and we had Q here, which was at 2.01. So this is the secant line. And now we had P here and Q right here at 2.001. So P was at 2 when x equals 2, and Q is when x equals 2.001. And this is the secant line. Do you see what's happening here?
Yeah, it's getting
closer and
vertical.
closer to the tangent.
Okay.
So, and we did this from by either side. We also came from 1.5 to 1.9, 1.99, 1.999. So we did this on both sides, not just on one side. So we came from 1.5 to 2, and we also came from 2.5 to 2 from both directions. And as we get P closer and Q closer and closer to P, this line gets closer and closer to becoming the tangent line as Q approaches P.
Okay, and that's why you get the error, because that's where the tangent line is.
I'm getting error because the denominator is x minus 2. And if I plug in 2, it's undefined. This expression is undefined. I cannot determine it like that.
Okay, that's not part of it. Okay.
Yes, so that's why we have to come from either one, either side, or just one or the other, it doesn't matter. We came from both sides to estimate this based on the numbers we have. Now, if the numbers go all over the place, something is wrong, right? If this is 2 and this is 5 and this is 3 and this is 100, then I cannot make a decision. But here it's very clear what's happening. It's 2, 1.11, 1.01, 1.001, 1.0000001. It's clear that it's approaching 1. And the same thing on this side. Getting closer and closer, 0.999, 0.99999, 0.999. So it's closer, so it's clear that the slope of the tangent is 1.
Okay, I get it now. Thank you.
Thank you. So this is the, yes?
Yeah, I had a quick question. I got a little behind because my computer was
Yes, I
like,
got your text. I saw that.
But when you go to the table, how do you like directly jump to the values? I got the table set part, but for some reason it's not letting me go straight to the values.
So did you punch in this?
Yes.
Do you have all parentheses as they are here?
Yes, and I set the table set to 0.001.
No. Second and table set. This is not important. This is not important.
Okay.
This is important.
Okay.
If you don't have the independent variable in ask mode, you can't plug in the numbers you want.
Okay.
So now
Yeah.
after you set that, they go to second and table, and then you enter the numbers you want. But you have to enter them. 1.5, enter, etc., etc.
Okay, thank you.
Better?
I got all the values. Didn't get how to do it myself.
Say it again.
I got all the values. I just didn't. I wanted to make sure I knew how to do it myself on the calculator.
Okay, so is it okay then?
Yeah.
Perfect. Okay. Good. So basically, now I would like to come back to this expression.
I have a question.
Yes, I'm ready.
How did we come upon that 1 over 1 minus x plus 1 over x minus 2? How did we find that?
y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1.
Okay, I see. Thank you.
Thank you. Good. So now I would like to simplify this a little bit. So the slope of PQ was, let me copy it. So it was 1 over 1 minus x plus 1 over x minus 2. Let's see if we can simplify this a little bit. Can anyone give us the least common denominator in the numerator? Anyone?
1 minus x.
Thank you very much. So then this one needs a 1 minus x, so the numerator is 1 plus 1 minus x. We agree with that? And this is x minus 2 over 1. How do we divide two fractions?
We
Yes?
we flip the
Denominator. Excellent.
denominator.
Correct. So 2 minus x over 1 minus x multiplied by 1 over x minus 2. Okay? Now, these appear to be the same, but the leading coefficient is negative, so I'm going to factor out -1 and change this into x minus 2 over 1 minus x times 1 over x minus 2. Is this okay so far? And of course, I'm going to simplify. So I always have to write, before I simplify, actually, I have to write this restriction. And also, x cannot be 1. We know that. Any questions so far on this simplification? I didn't finish, but is everything okay?
Why did we put that 1 minus x on the numerator of denominator?
When I add 1/2 to 1/3, the least common denominator is 6. 2 times what is 6? 3. 3 times what is 6? 2. So 3 times 1 is 3, plus 2 times 1 is 2, to get 5/6. So this denominator here is 1. So then if the least common denominator is 1 minus x, it means that this has to be changed into 1 minus x over 1 minus x. I cannot add fractions that don't have the same denominator. So then I have 1 plus 1 minus x. So now I have 2 minus x over 1 minus x, and then flip the denominator. Is this better?
Yeah, I see now.
Perfect. And then we simplified, stating these restrictions. And I haven't finished, so I'll continue here. So now when you rearrange this, right, as negative x plus 1 and factor out -1, right? So we have 1 over negative x minus 1. These two will cancel each other. So this is x minus 1. X minus 1. So remember, our point was 2 comma -1. Tell me what happens here. What will be the slope when x is 2?
1.
Exactly 1. But I didn't want to do this because this is a very special, simple case in which we could have done that and we could have determined the slope. Because it's simplifiable, I can simplify the denominator, which creates the problem. The denominator is the problem, 2 minus 2 in the denominator. But this will not always happen for all functions. Okay. So I'd like to continue. Any questions for me? Okay, so this was everything we discussed here was basically 2.1. So please add the 2.1. It was not a secret. I just didn't want to start with that. So now in 2.2, we're going to talk about the limit operator. Okay, so we already know that the limit is an operator, like the square root applied to a function, like the cube root applied to a function, like natural log, like any of that. But it looks different, right? So I have to have when x approaches something, when x approaches a. So this is what we're going to discuss for the next few minutes. What does this mean? How is it used? Where does it come into play and why? Okay, so we're going to talk about it. We know one thing, that we can apply this to the concept of when p gets closer and closer to q, which means h approaches 0, the slope of the secant line pq equals the slope of the tangent at p. So this is what we've seen the first time, the limit operator being applied to something. Okay. There is way more to it than just the slope of the secant becoming the slope of the tangent. Okay, so let's take a look at a function. So here's a function f of x. And here's a point. And I'm going to say that this is A, lowercase a, and this is uppercase L. So now I would like you to imagine motion, meaning and tendency. Okay, so let's say I come from the right-hand side of A with numbers greater than A. So I come closer and closer and closer and closer and closer to A without, so obviously this is very clear. We don't have to write it, but I'm going to write it a couple of times. When we say X approaches A, we mean X does not equal A. So stay with me, please. So as X approaches A from the right, let's follow the function and see what it does. What is the tendency of the function to do? To get closer and closer to what? Okay, one more time. As X approaches A from the right, the function values get closer and closer, closer and closer to
L.
That's it. Now let's see from the other side. As X approaches A from this side, the function values get closer and closer, closer and closer to
L.
That's it. So this is the tendency or the limit. Okay, how do we read this? The limit of f of x as x approaches A from either side the limit of f of x as x approaches A from either side is L. If L equals a number, not infinity, then the limit of f of x exists. Only if it is a number. If L is infinity, then the limit does not exist. If you cannot say what L is, then the limit does not exist. Here's another situation. Again, I have A here, I have L here. Question. The limit as x approaches A from f of x. Of course, this is f of x. Does it exist or not? Before you say anything, we are only talking about tendency. We're specifically saying this. So will the limit exist? As x approaches A simultaneously from either side, do the function values, do they get closer and closer, closer and closer to L?
Would it be yes?
Yes.
Yes. So what we learn here is the function does not have to be defined there. As long as the limit from the left and the limit from the right equal the same number and there is a number, the limit exists. So we also have something called limit of f of x as x approaches A from the left, meaning with numbers smaller than A. This is the left-hand limit. And of course, we have something, this is a power minus. X approaches a power plus, of course, is the right hand limit. So this clearly states this is true only if the limit as x approaches a from the left of f of x equals the limit of f of x as x approaches a from the right. So if I say the limit exists, it is guaranteed that both sides go to the same point, approach the same point. This is tendency, not equal. So, of course, now you know what follows. What do you think about this? What does the limit of this function, this is my f of x now, as x approaches 4 from the left equal to? What does the limit of this function as x approaches 4 from the right equal to? And then the conclusion for limit of f of x as x approaches 4 from either side.
Is it 5 from left and 7 from right? And it does not exist on the both side.
So, and here,
7
yes, very good. And here is
doesn't exist.
D and E. It does not exist. How come? Because it does not approach a number. It does not approach a number. It has to be a unique number. One more time. When we say the limit from either side is L, we automatically mean, and this has to happen, that the left limit and the right limit exist and are